let's dive into some fascinating questions, if you do say so yourself.
We'll be the judge of that.
We'll be the judge of that. Yuba City, California.
What kind of city?
Yuba.
Yuba.
It's right next to Yabba Dabba Dooba. Did you ever see the alien take a poop? Is the human connection scientifically essential for learning?
I love that.
Isaac Asimov's foundation. It is awesome.
Oh, yes, yes.
Gravitational entropy. Flatlanders and 4D space.
Okay, now I'm all confused. This is Star Talk. Cosmic Queries. I got with me Chuck Nice.
Hey,
Chuck.
what's happening, Neil?
All right, this is a grab bag.
Yes, it is.
What's the verdict on how long it takes me to answer a question?
Believe it or not, because they put out this to the audience, they like the longer answers.
The producers.
Well, the producers
data
want us
on
to
this.
go as quickly as possible because they want to get more answers in.
Yeah,
but they asked the people, and the people like the long answers.
And people spoke.
Yes, the people have spoken.
Have risen up.
That's right.
All right. I won't do it on purpose. It's just it's organic when it happens.
It's the passion of the universe flowing through me. This is Alex K, who says, hello, Dr. Tyson, Lord Nice. Alex from Bucharest, Romania here. Bucharest. What keeps me up at night is Flatlanders and 4D space. I often hear...
I love it. That's some geeky stuff right there.
Yeah.
That's that. We give him a geek award for that.
He says, I often hear that dark matter or dark energy could be the 4D leaking into our 3D space. But living in 3D space, can we ever actually observe a truly 2D space? And if not, wouldn't that mean 4D beings couldn't interfere with our world either, just as we don't notice any real 2D beings?
I see where he's coming from.
Yeah.
I think what he's saying is, if there were 2D creatures in our world, how would we ever know?
Right.
All right. So holding aside the fact that if you're 2D, you have no thickness.
Right.
If you have zero thickness, how does any light or matter even interact with you? Because light and matter
reflect.
Yeah, okay. But
right.
So let's just ignore that very real complication, but let's ignore it for the moment.
Okay.
Okay? There was a cartoon back when the internet was a fun place to just explore humor and cat videos.
Oh, yeah.
Those
were the days.
There were two illustrated creatures, and one of them was 2D. I forgot their names. It's like, hey, Joey, I just became 2D. And he's looking at him. He looks a little flat, but he wasn't sure. And all he did was turns sideways and he disappears. Disappears. He turns sideways towards your sight line.
Right.
And then they laughed and they were just having a good time. Those were the days on the internet. Man.
Yeah.
Man.
Now it's nothing but Nazis. It's Nazi Yahtzee.
Okay. So it implies that even if you're invisible edge on, that the light is somehow still reflecting off of you face on.
Right.
Okay? So a 2D world in front of us would be completely visible. You would see light reflecting off of their substance.
Right.
Their 2D substance, whatever that is.
Right.
Only when they go sideways do they disappear.
Okay. From
your view.
Right.
Because they have no thickness. So, we three-dimensional creatures, would four-dimensional, spatial dimensional creatures be able to see us? It means there must be some orientation we can take where we disappear to them.
Right.
Just following this sequence. I can't picture what that would be.
I can't either because I'm 3D. So I'm looking around, everything's 3D. So what do I look like to a 4D guy? I don't know,
I don't know how a 3D person would hide from a 4D person, which way to orient ourselves, the way a 2D person can do that to us.
Mm-hmm.
I don't know how you do that. I have to think about it some more. What I do know is, and we've said this before, if you're looking at a 2D creature, you can see inside their organs, their inner organs. 2D people can't see because they have skin this line,
Right.
which is their 2D skin. They can't see through the line, but we can see directly into their bodies.
So I look really ugly to a 4D person.
4D person, they'll see all your guts.
They just see guts and yeah.
And I think the first thing we do when we have 4-dimensional beings is to make them medical doctors and have them perform surgery.
Right. It's a game of operation for them. Nothing to it. Take out wrenched ankle. We're good to go.
I forgot about that game, Operation. I wonder how many people became doctors out of that.
You know, that's a problem. If they did, they're probably pretty bad doctors. I'm just saying. Like, if the game Operation was your inspiration, you know, they're standing over the operating table with a pair of tweezers. I don't know what to do.
Well, they're trying to settle malpractice suits.
Right.
So that's what I know. And for me, that's the most intriguing thing.
Yeah.
That you can see inside of somebody who's otherwise completely enclosed in skin. In the same way, the 2D person is completely enclosed by a line.
Right. And you can see what's inside that line.
Inside that line.
Right.
So that's the best I can give them on that question.
Okay. Yeah. Well, that's cool, man.
Otherwise, yeah, I don't know where to take it.
Yeah. All right. Well, this is Jeff Drumsites. And Jeff Drumsites says, greetings, Dr. Tyson, Lord Nice. I recently began watching Apple TV's version of Isaac Asimov's Foundation. It is awesome.
Oh, yes. That's the one where they have the hereditary rulers who are clones of each other. That's the limit of heredity.
That's it.
That's it. You know,
all the lineage is just a cloned line that you have.
Right.
Dawn, day, and dusk. So there's...
And day is the ruler.
Day is the ruler.
Yeah.
Dusk is the wisdom.
And dawn is learning.
And dawn is learning.
Okay.
And they are in that constant cyclical state of replacing one another.
Right.
And at a certain time, they have to be destroyed and move on. It's pretty wild. But anyway, he says this. When I was a child in the 50s, my dad's popular science magazine depicted the idea of a space elevator, which they have in Foundation. Trantor is the planet on which the rulers live, and the way you get to Trantor is from a space elevator. So anyway, my question is, he says, is the Trantor Starbridge or any type of space elevator technically conceivable? Jeff Seitz in Gallatin, Tennessee.
Okay.
Or Gallatin, Tennessee.
The answer is yes.
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 But so some things to take note of.
Okay.
The motivation for a space elevator is you can get to an orbit without ever firing a rocket.
Yeah, there you go.
You just, all right.
You just get on the elevator.
Get on the elevator.
Third floor women's lingerie. And where are you going, sir? Oh, okay.
And is that still a joke? Lingerie? That was the big...
I got it from Bugs Bunny.
Well, okay. The real question is, what is an entire floor doing of just lingerie?
Yeah, exactly.
Nobody's asking that question.
Right.
So I have a friend who composes space music, and she created an album called Space Elevator Music.
That's funny. Right.
Right. On Earth, a space elevator would take you to the geosynchronous orbit, because that's the only orbit that appears to hover over Earth.
Right.
Its corresponding spot on Earth. Any orbit that's closer, it will speed up ahead of the orbit of the Earth.
Right.
Okay? So to have an elevator go from a position on Earth's surface to a position in orbit, it has to go to geosynchronous. And on Earth, that's 23,000 miles. So you'd be sitting in an elevator going 23,000 miles.
Wow.
If your elevator were going 1,000 miles an hour, how long would it take you to get?
23,000 hours.
No.
I mean, 1,000 miles an hour, 23 hours. That's a full day.
It's still a full day.
It takes you one day to get, and we already get to space quicker than that.
Yeah, I know. That's right. Okay, so the idea was getting to space must be so hard with all these rocket engines and things that we need another way. But access to space now is routine, and the price continues to drop, especially because of innovations in SpaceX. Elon Musk, and it was a big mission statement of his with regard to SpaceX. You hardly hear talk of a space elevator today.
Anymore. Right.
It was a solution to a non-problem. And you know what fuel we're using? Hydrogen and oxygen.
Right.
Well, there's some solid rocket boosters, but the main tank is hydrogen, twice as big as the oxygen tank. And it's liquefied. You put them together, they will combine in H2 and O.
Okay.
So the exhaust is what?
Drinkable.
So, yeah, the exhaust is just water, but it's highly exothermic. Right. So space elevator is a cool technological achievement, but I don't see it.
Highly impractical.
I don't see it happening.
All right. Well, there you go. That's but also though, that series it starts off boring as hell, but then it really gets great. So,
nope, that's lame. Ready? Do you harbor questions about the universe? Some long-held bit of cosmic curiosity lingering within you? Or questions about anything at all? You can become a Patreon supporter of Star Talk. You have access to our exclusive question line on our website. Those are where we draw our questions for our cosmic queries.
Some of the most extreme objects in the universe.
Star Talk is a work in progress where we, every month, come up with some new way, some new idea, some new understanding of how to bring the universe down to Earth. And we could not do that without your support. Thank you. And as always, keep looking up.
All right, this is Raphael who says, hello, Raphael Vigod, in Toronto, Ontario. If a superintelligent extraterrestrial offered to grant you the answer to one specific question, what would you ask? Now, don't think too long because you have to give your immediate response. And we're only here for a few more minutes before their next interstellar train leaves.
Okay.
So
there's a question I have every night.
Go ahead.
Is the human brain sufficiently smart to figure out the entire universe?
Wow.
That's a question I want answered. Because if it's not, then I'll buffer my expectations.
Right.
But if it is, then
we
onward we march.
Can go from there.
Right.
The universe is your oyster.
Right.
At that point. But that's a really interesting question because basically, are we too stupid?
Yeah, I ask that every night.
Like we might just be like the whole quantum thing, and we're like quantum.
Right.
Like maybe we're just dumb.
and it wouldn't be mysterious if we weren't so dumb.
Right.
But yeah, it's obvious.
Yeah.
For these reasons.
Wow.
But we can't even understand the reasons. So yeah. So I want to know. Inquiring minds want to know.
It's a good question. I mean, I like it. Me, I would like to know: are there cheaper eggs somewhere in the universe than where I buy mine right now? Because they're hugely expensive.
That's really that's your question. My son, you can ask any question in the universe.
Right.
I need some cheaper eggs.
Yeah, no. What would I ask if I really wanted to know anything? Mine would be what happened before the Big Bang.
Really?
Yeah.
Okay.
Like, and I don't mean what happened. I mean like, because we know what happened before the Big Bang. The Big Bang happened. So what caused it to happen? What was there before? Give me the lay of the land before the Big Bang.
Okay.
That'd be kind of cool to know.
It's an origins problem.
An origins.
Yeah, and origins questions are always the most challenging in science because you don't have other examples to compare it with. And until you do, you're kind of making stuff up.
Exactly.
Right.
Yeah.
I mean, what's the origin of the Earth? No one knew until we saw planetary systems getting formed.
Right.
Then we could say, it takes this long with that time frame, at this distance from the host star. You can formulate questions that have value. But
yeah. But it'd be kind of cool if the aliens were, or the terrestrials were just, extraterrestrials were just like, your universe is just one of 15 million that we've been to thus far, and before this is what happened. Two other universes got together after a night of drinking and bang, Your universe was born. So anyway,
Can't believe you included alcohol reference to that.
this is Marcus Munzlinger. And Marcus Munzlinger says, hello from Germany. Or should I say, no, never mind. I'm not going to do it. I'm not going to do it. Did you ever think, in my accent, pronounce sink, about the alien in Alien not needing any digestive organs since its blood is acid? So all human flesh it eats is directly dissolved into molecules, so the alien doesn't need to produce poop since it can use 100% of its food. Or did you ever see the alien take a poop? Love your show.
Who knows about digestive tracts? I mean, we played with Superman's digestive tract, and he was an alien.
Yes.
Right?
That's
and
right.
We solved that one, I think.
Yes, we did.
He has a super digestive
He has
tract.
a super digestive
And so
tract.
that means
and
it's
everything about it is super.
including the gaseous effluences.
That's right.
Right. A plant-based alien, however, wouldn't have any such waste products, or its waste product would be oxygen. That's pretty good.
Right.
Right. So I don't, I'm cool with it.
Yeah. Yeah. It doesn't make a difference. It doesn't.
Right.
A poopless alien is totally fine.
That's right.
I mean, there's nothing wrong with a poopless alien.
But then they have to rewrite that book, that kid's book.
Which one?
Everybody poops. Everybody
Right.
poops. This is an old bad dad joke.
Go ahead.
What Italians call suppositories?
No, I don't know.
Innuendo.
Oh, no. No, please. No.
Yes. You know that's good.
Oh, no.
You know it's good.
Oh, man. All right, here we go. This is Matthew Landreth, who says, greetings, Star Talk. My name is Matt, a globe-trekking teacher who has lived and taught around the world.
Teacher in the house.
There you go. Through these experiences, I have seen how much learning depends on human connection. Dr. Tyson is a fellow teacher and science communicator. You know how ideas ignite in others. Science fiction imagines AI tutors or digital replicas guiding future generations. If an AI could replicate a teacher's knowledge, style, and personality, would that truly be teaching, or is the human connection scientifically essential for learning?
I love that. So, a couple of things. If you are teaching today with methods, tools, and tactics, and then I clone that, I'm not given any reason to think that your clone would not be as effective as you are in those situations.
Right.
You have a life experience, a training, where if someone whose profile doesn't fit that of other students, you will readjust and repackage what you know works so that you have a new pathway to reach the intellectual curiosity of that student. I don't know that AI can do that just now.
Right.
AI can, ape your style.
Right.
It can, dig up some content.
But it can't intuit something different that might be happening in a student and then make an adjustment.
And make an adjustment, especially if students change, they mature, or they regress.
Right.
Right. So I think that frontier, at least from my foreseeable future, that is the future that I can foresee, remains in the realm of the inventive, creative teacher.
Interesting.
Yeah.
Yeah, very cool. Very cool. The human condition is still a very important part of teaching.
No, it's the ever-changing human condition.
Or the ever-changing, yes.
Yeah, because
exactly.
otherwise I can memorize everything in that moment.
Right.
And then that's watching it go forward in time and be nimble enough to navigate that. That's the real test.
There you go. All right, this is DJ Sipe. He says, this is DJ from Maine. I've been curious about the properties of space-time and gravity. We know that gravity is the result of objects with mass bending space-time. To me, this implies that space-time is naturally flat, but doesn't explain why. Is there some force or property of space-time that acts to restore its natural flat state once an object and its gravitational field move away. Perhaps some form of gravitational entropy.
Ooh, I like that idea.
The idea of gravitational entropy.
Oh, yeah, yeah.
So he's looking at this whole rubber sheet type.
Yeah. So, I mean, all we can say is, by the way, it's not just matter that will bend space's energy as well, because matter and energy are equivalent through equals mc squared.
Nice.
So just be more complete addressing it that way. Since the curvature of space and time is the manifestation of matter and energy, if you remove the matter and energy, there's no reason for the space-time to be curved at all. I'm given no reason to think that space would have any shape other than flat after you remove the items that would curve it.
Right.
Keep in mind, however, the expanding or contracting universe itself has a shape unrelated to the gravity of objects it contains.
Right.
And this is why we talked about it as an open universe, a closed universe, or a flat universe. And those are large-scale properties that are not related to just one galaxy or another. Yeah.
There you go.
Mm-hmm.
Very cool, man. That's a great question, DJ.
Yeah.
No. These people are thinking. I love it. This is Keith Johnson from NorCal. And Keith says, can we think of a universal now based on the point of view of an observer? In other words, my now. Can we analyze a particular star in the night sky and determine its probable lifespan and then say that this particular star does not, in all probability, exist anymore in my now? Its ghost is seen as a shadow of light arriving billions of light years after its demise.
So what's the question in there?
So I guess he's saying, is that the case? Like when we look up, are we seeing stuff that's not there?
We see things not as they are, but as they once were. We're not worried if they're no longer there because that's not a real thing we can interact with. We're interacting with a light that is currently reaching us. And when that light was emitted, it was alive, whatever it was.
Right.
So
we're looking back in time, but we're looking at that time. So it doesn't make a difference. Because we're looking at that time.
Correct. It doesn't make a difference.
Right.
So might as well speak of it in the present.
Right.
The star exploded last night. No, it was 1,700 years ago. But what do you gain by that, right? Other than like a nerdy kid saying, yeah, you got it wrong. It's not really in the now. So the fun part would be find a galaxy 33 light years away. Find a galaxy 33 million light years away.
Okay.
And then if they all held up mirrors and you looked at those mirrors, you would see the dinosaurs going extinct.
Oh, wow.
Because it's 33 light years there
and 33 light years back.
66 years
so
into the past.
Look at that.
Yeah. So, yeah, it's fun to think that way.
Right.
But our speeds are not high enough to generate significant relativistic.
All right. Well, there you have it. Still a fun question, though. Thanks for the fun question, buddy. All right. That was Keith, and this is Anthony Calamani.
Tony Calamani. Everyone with a tiny voice does not come from Brooklyn, okay?
And they do in my world. All right. This is Anthony, and he says, greetings from Seattle, Dr. Tyson, Lord Nice. My 11-year-old son and I were discussing the pitfalls of fictional time travel within the space-time continuum.
Okay.
Understanding that you have pointed out on many occasions that one would have to calculate not only the space-time location on the target on Earth as it rotates on its axis, revolves around the sun, and the trajectory of our solar system moving through space, but also as our galaxy moves through the universe. Well, he covered it all. Look at you, man.
Well,
this was way to go. Our question is, would one have to know the center or origin point of the universe to guarantee an accurate space-time coordinate, or would relative distances be enough even if the universe isn't expanding in uniform fashion? So he's taken into account the expansion of the universe in the time travel equation as well.
Yeah, but I'm trying to figure out what he's getting at. So
he's saying, I'm going to go and come back. That's what he left out. So I got to go back, and then I got to come back to my time. So
is he going into the past?
Into the past. So my coordinate, okay, what am I going to need? Can I accurately predict with not only rotation of the Earth, but the solar system and the galaxy moving and also the expansion of the universe? Can I accurately predict the point where I got to go back and be back in time? I traveled at the speed of light or faster than the speed of light, went back in time, and then come back to that same point where I left.
Right.
Can I do that?
Rich Scott, I think, would say you can.
Okay.
Using sort of mathematical trajectories in the vicinity of black holes. I have to trust him on that because I can't duplicate those calculations.
Okay.
He's studied this stuff like professionally.
Okay.
So in fact, he wrote a book, Time Travel in Einstein's Universe.
All right.
So in principle, yes. But is there a no disruption conjecture where you're not allowed to prevent your parents from meeting, thereby preventing you from being born, thereby preventing you from coming back to try to rectify things? So,
hey, Marvin.
what? Oh,
I think I got that sound you were looking for, Marvin. No, it's me, your cousin.
so Marvin?
No, that's right. He was calling Chuck Berry. He's Marvin.
He's Marvin.
It's me, your cousin Marvin.
Hey, Chuck.
Hey,
it's me,
Chuck.
your coming Chuck.
Right.
Yeah. Chuck Berry. Marvin Berry.
Marvin Berry.
Yeah. From Back to the Future,
Right,
if you're living under a rock. So, and by the way, I think we talked about this on another episode about gin particles.
Yes, we did, which I love.
And so that's a gin song.
No, we did an explainer.
Explain it. So that'd be a gin song.
Gin song. That would be a gin song.
A gin song.
Because it didn't exist until Marvin Berry put the phone out and let Chuck Berry hear Johnny B. Good.
The song that he wrote.
He wrote.
And then Marty picks it up later.
Right.
Right.
So Marty gets it in the future, but Chuck gets it in the past.
Right. And so that song was never actually written.
Never actually written.
Right. It just lives in a time loop.
Lives in a time loop.
Yeah.
I love that whole gin particle thing, man. It's the gin stuff.
It's a gin song.
Yeah.
So
what was the other movie we did that?
It was Somewhere in Time.
A woman with a
Somewhere
with a
in
piece
Time.
of jewelry or something.
Somewhere in Time.
Somewhere in Time. That's the name of it.
Yeah.
Okay. Cool.
It's a romantic story.
Oh, that's why I don't like it. Okay. So anyway,
I was gonna say rom-com, but it's not a com.
Oh, okay.
It's just a rom.
Just a rom.
But it had Christopher Reeve in it.
Oh, okay.
You know, it's Superman.
All right.
After Superman, he did it.
All right.
But he's a handsome guy, you know.
Yeah, I mean, listen, they can't all be winners. He did Superman. So anyway, Rich Gott says that this can happen.
Yeah. So I can't follow his math.
Okay.
But I mean, I follow it, but I couldn't derive it.
Right.
I mean, he's in it.
You got to repeat, right?
Yeah,
he does it.
He does it.
He does it.
He figures it out. So I just recommend that book of his.
Okay.
Time Travel in Einstein's Universe.
Yeah.
Mm-hmm.
Very cool. Great question. And I just like the fact that you're talking to your 11-year-old about the universe and time travel in such specificity, which is fantastic. All right. This is Todd Chambers, who says, hello, Dr. Tyson. The Todd Chambers here from Yuba City, California.
What kind of city?
Yuba. It's right next to Yabba Dabba Dooba.
Or what's that, 1210 from Yuba? Or what's that, the train?
I don't know.
No, Yuma. Yuma, not Yuba.
310 to Yuma.
310 to Yabba Dabba Duma. Okay, go on.
So he says, I'm a retired naval officer and earth science teacher.
Nice. That's a nice combo right there.
That's a great combo, yeah. He says, does light ever do any work? Well, it does light work. No. He says... I'm sorry, I couldn't resist. I had to do it. He says, does light ever do any work?
But it does do windows.
Right. And what would that look like to an observer of the night sky?
All right. So there's something called a solar sail.
Yes.
Where you have a big sort of mylar, low mass, high reflective. Mylar is like what they wrap around the
balloons.
Balloons are mylar balloons.
Yeah.
And I think mylar might be what they wrap around the marathon
runners.
The marathon run.
Yeah.
There might be some mylar variant.
Yeah.
Flexible, shiny, highly reflective, so it keeps your radiant heat in.
Right.
So it can be warm without it being a blanket.
Like, right.
Right? Because that's all a good blanket does is prevent your heat from getting out.
Yeah.
We did a whole explainer on that.
We did.
Like
on blankets.
On blankets 100 years ago.
Blanket. I love you, blanket. Okay.
Right. 'Cause many people think if you put a blanket on something, you'll make it warm.
Right.
But no. This has actually been built by funds of membership of the Planetary Society.
That's right.
A good friend of Star Talk is Bill Nye, who is the CEO of the Planetary Society.
Right.
They funded, built, and launched a solar sail. And the way it worked is because it was a test prototype. So it's orbiting the Earth, and if you want to see if light can do work, you open up the solar sail, angle it in ways to your advantage, and see if sunlight can press on that solar sail and increase your orbit around the Earth. And it did.
Oh, snap.
So the light is doing work.
Light is doing work.
Yes.
Wow.
Okay. And
reflection as propulsion.
Yes.
That's amazing.
Yes.
That's amazing.
Yes.
Reflection as propulsion.
Yes.
That's awesome.
And there's something called the Breakthrough Initiative, which is a chunk of money. Some billionaires participated in this, where it gives awards for new inventions that we think we need, but it just takes some innovative people to do it. Someone wanted, when are we going to have a tricorder?
Right.
Just a portable thing, and then you have all the reading on it. Okay, that's a useful thing. Why not?
So cool.
All right. So one of them is these nanoprobes. So nano means a billionth of. So people have abused the word.
Right.
They just use it for anything small.
Well, that's because Apple came out with the nano, and that was the end of it.
That was the end. Yeah, there you go.
That was it.
They have these nano cells, so they're like, they fit in your palm. They're like the size of a postage stamp. Attached to it is a huge mylar sail. Okay? They get deployed in a rocket launch. Then you have ground-based gigawatt lasers.
Oh, that is amazing.
Beaming these things in the direction you want them to go.
And that propels them forward.
Correct. And the goal is to send these to Alpha Centauri. And you can accelerate it up to like 20% the speed of light.
Yes, because like there's nothing to impede it because you're in the vacuum of space.
You're in the vacuum of space.
And so the laser is
and the thing doesn't weigh very much.
That's amazing.
And the sail is huge, and the laser is powerful.
That's awesome.
Right. So, and you can pack a lot on a postage stamp chip.
Right.
Okay.
Yeah.
Like temperature and radiation field and magnetic field. They can do. And so that's the goal. And so let's see how good you are at math.
I'm not. Let's not.
If it reaches 20% the speed of light, and Alpha Centauri is 4 light years away.
Okay. So
how long does it take to get there?
It'll take 20 to wait. It's 4 light years away, and it's at 20%. So 1 light year would be 1 year. So that's 4 times that, right? No, 5 times that.
Is that your final answer?
Right. So it's 20 years, right?
Okay, now I'm okay. Yes, 20 years.
See,
yes.
Now you know how this craziness works.
Okay.
Because that's how I do math.
We just exposed the wiring of your brain in that moment.
I'm sorry. You see how freaking nuts it is up in there, but I come out to the right stuff. But anyway, 20 years.
Yeah, if you go 1/5 the speed of light, and if 4 light years, it'll be 5 times 4 is 20. Right. So 20 years, that's within people's lifetime who are funding the thing. And so that was the goal. Okay. However, it gets there, now it's to send a signal back.
Oh, well, that's crazy.
Oh, that's at the speed of light.
Right.
So when do you know what it found there? After how much time?
24 years.
Chuck!
Yeah. Super
We'll
cool.
give you an honorary degree just for just being on the show.
Yeah, I was going to say yes. Well, you can. You got like 30 of them up there.
No, 27. That's
Okay, nobody's counting. All right.
Stop.
This is Dusty Rock Creations. And Dusty Rock Creations says, hello from Quebec, Canada. Quebec. And he says, this is Jean-Francois Roch, who says, here from Dusty Rock Creations. Oh,
You think?
He's dropping names. He says, Mr. Tyson, Lord Nice, let's dive into some fascinating questions, if you do say so yourself. He says,
We'll be the judge of that.
We'll be the judge of that.
All right.
He says, supermassive black holes at the heart of galaxies hold the key to understanding how galaxies come into being.
Maybe. Yes.
Maybe.
Let me tell you why it's a maybe.
Okay.
Because the supermassive black hole has like the big ones, like 1 billion solar masses. Give them 10 billion, but billions. We can Carl Saganify it. Billions.
Right.
So the mass of a galaxy, however, is hundreds of billions times the mass of the sun. So maybe the black hole nucleated some things to begin with, but the mass of the galaxy swamps the mass of the black hole.
Right.
So there's a limit to how much you're going to credit the black hole for the whole damn, the kit and the caboodle.
Gotcha.
Okay. So continue.
That's a very good point. He says, is it fair to say that entire galaxies will inevitably end up being swallowed by their own black holes and disappear forever?
No.
Yep. There you go. Thank you for being my everyday source of wonder.
Oh, thank you. I love that.
Chuck, did you get my name right? I don't know.
Okay, what's the name?
I don't know if I got anybody's name right. I said his name was Jean-Francois Roch, but
R-O-Q-U-E?
R-O-C-K.
Oh, Rock.
Yeah.
Rock.
But Jean, Gean dash Francios. Francois.
Yeah.
Right? Rock. So maybe I got it right.
Probably Rock.
Rock.
Right,
Yes.
I bet it is.
Exactly.
Okay, you did pretty good. I'll give you a B+
Yeah,
on that.
I mean, I did the best I could, but, listen, truth is, if I mispronounce your name, I did you a favor, okay? Because now you got an alias, okay? You got a Star Talk alias.
So here's the thing. A black hole is really tiny relative to the galaxy. They're big. They're like the billion solar mass black holes are like multiples of the size of the solar system. But that's still tiny in the middle of the galaxy. Okay.
Right.
If it's going to eat the galaxy, the matter that's orbiting it has to stop orbiting and fall straight in.
Right.
And that's just not going to happen.
No, it's not.
Okay?
All right.
Maybe stuff nearby, here's what'll happen. A star will come nearby and tidal forces will stretch it out and you'll get this wispy stream of gas spiraling in down to the black hole. Then it can make an accretion disk. That's what we call them. This is that's the holding place. It's taxiing, ready to go into the black hole. As it's falling towards the black hole, it's slowing down from the friction of all the other material there, and that energy has to go somewhere, and it goes to heating the accretion disk.
Okay.
So hot, millions of degrees, that it radiates ultraviolet and X-ray light. So the X-ray telescopes were the first telescopes to discover black holes, because we did the math on what that should look like.
Right.
Point is, you only get these accretion disks from things that are very close.
Right.
That can be that trip on the matter that'll slow them down. Anybody else doesn't even care that there's a black hole.
Right.
There.
Right. Yeah, it's like when you explain that even if our sun became a black hole,
Correct.
we would still just be orbiting a black hole now that is our sun.
It doesn't have extra gravity.
It doesn't have, right.
Correct.
Because the gravity is due to the mass, and
total
the
mass
does not change.
Yeah, if you turn it wouldn't happen naturally, but if you magic hands to do it, it would just be a black hole, and if it's the same mass, we'll just still orbit
around that. So now
we freeze to death.
We'll freeze to death. But Jean-Francois actually has made me have a question.
Francois.
So when two galaxies collide,
Mm-hmm.
do the black holes then actually fall into one to another and become one giant black hole around that galaxy?
They will very likely eventually find each other. Okay? They will probably, you look at the dynamics of colliding galaxies. Galaxies are mostly empty, by the way.
Right.
I had in one of the questions in the Merlin book, what are the chances of two stars colliding just in the galaxy?
Mm-hmm.
And I said, if there were 4 bumblebees in the continental United States, the chances are greater that 2 of them would accidentally bump into each other than 2 stars collide in our galaxy.
Damn.
Did my brother do two bumblebees that hit each other? Had like a
little bumblebee hickeys.
Just bumblebee stunned
Right.
Clouds over their heads. So it's empty. So when the galaxies collide, they will pass through one another.
Right.
It'll be this cosmic ballet, choreographed by the forces of gravity, and it'll pulse like that as they pass through each other, come back, collide again, and they keep doing this until it settles down, because there's energy dissipated each time that happens. And the settling down puts the heavy stuff in the middle, the heavy, slow-moving stuff in the middle, and the faster, lighter stuff in the outer region. That's when the system is settling.
Right.
And the black holes, they're the heavy thing in the middle.
Of course.
So they'll find each other in the middle. They'll merge, and you'll get a black hole twice the size you had before.
Wow.
Yeah. We got time for one more question.
Oh.
This is a very grab bag. I love it.
This was
It's
a
good.
great one. Yeah. This is Patrick. He says, Dr. Tyson, Lord Nice, just another science nerd here from Texas.
Love him.
What if space-time itself is a super solid lattice where defects create natural time loops that erase paradoxes, and the so-called mystery echoes LIGO is hearing are actually the fingerprints of that lattice, meaning we've already stumbled onto evidence of a new state of reality and missed it because we were looking through the wrong lens.
Ooh.
Wow, Patrick.
I like that. What I like about it is he's thinking of space, the fabric of space-time, as a medium.
You're right.
Okay? Mm-hmm. And if you think of it as a medium, we sort of already do, but we think of it as sort of fabric rather. Lattice is a stronger entity than just fabric.
Right.
Right? If it's a lattice, then you can think about like crystal lattices.
Right.
And crystal lattices, things happen within them. You can have like light behaves in certain ways in one direction versus another. Sound goes in different ways because the lattice forces energy to pass through it differently depending on the direction that the energy goes through it. And so we would have to propose a series of experiments to check whether phenomena that unfolds within the lattice is different when viewed at different angles. That would be, I think, based on my understanding of the geology of a lattice, the rock science,
Right.
Of lattice, of what a crystal would be. So I think he's saying, without saying it, that maybe the entire fabric of the universe is a crystal. I think he's saying that without saying it.
Wow.
And we invented in our lifetime liquid crystal.
That's right.
That's
Just your
the wristwatches
computer,
used to
and,
have.
not your computer,
your screens.
all your screens.
Yeah,
your
liquid crystals.
TVs.
So this, yeah, I don't have a good answer to that other than that's intriguing.
Yeah.
Yeah.
Well, the universe is a television. There you go.
Back in the day, nobody has, they're LEDs.
LEDs now.
No, not LCDs.
Light emitting diodes, which are better.
Liquid crystal displays,
Yeah,
right.
No more LCD TVs.
Right. Yeah. So anyhow, I like it. I like it. It's very creative.
Thought. Very creative.
Very creative.
Yeah.
Maybe you can develop it further.
Yeah, I doubt that.
Why?
I'm just hating.
If he came up with that question,
Of course not. No, I think it's brilliant what he came up with. No.
then we're going to find out he's a 10-year-old kid.
Now that would be impressive. Yeah. No, it's very cool, man.
All right. So we got to end it there.
Oh man, that was
sad.
a good one. These
That's
people,
sad.
you people, you're amazing.
Chuck, always good to have you, man.
Always a pleasure.
Yeah, another installment of Star Talk Cosmic Queries, Grab Bag Edition. Neil deGrasse Tyson wishing you to keep looking up.